Well, folks, this is my North Shore Road video at the 10.2 mile mark. This is an incredibly diverse uh, area with various different geological formations. Basically, we're looking to the south of North Shore Road in Lake Mead National Recreation Area. Another look further down this wash. And the video will be start about a fifth of a mile down this wash. And today is January the 15th, 2022. And as you can see, it's a real beautiful day today on the 15th of January, and that's Black Mesa in the background. And we'll basically be walking back towards my truck. And this is just a small area of interest along this wash. There's still quite a bit to explore, and I do plan on coming out here again and making other videos. But upcoming is this very interesting lava flow over this red sandstone material. This is another one of those examples where lava has come in contact with wet sediment. There's been a reaction, and the lava uh, starts to break up into various pieces, and the wet sediment mingles in with the lava to form these interesting structures you see here. This red sandstone somehow to me looks kind of different. It's more like it's coming from the Horse Springs Formation. But that right there, that vertical uh, feature of this lava is pretty interesting. Normally it's just horizontal, but it's interesting how it just flows up and down like that. What's interesting when you look at this particular formation here, the area at the contact of the lava, it appears to be different. Obviously, it's going to be subjected to a lot of heat, but it's uh, it's extremely hard compared to a few feet down. Here's a series of slides in this one area here. Give a little better detail, hopefully. One thing I have noticed in this area, in this formation, is veins of gypsum, which adds to this interesting story. What's happening here? Apparently, there was a lake on top of after all this lava event here, and the gypsum seeped down. Calcium sulfate seeped down into the cracks. One thing you can notice, the larger pieces of basalt are all vesicular. So this is an interesting picture here. Notice several interesting features here. This one area right here, I could spend all day taking pictures, and of some unique characteristics of how the sediment has mingled with the lava and it's given all these unusual looking features and structures. More of that pepperite looking appearance. Just love walking through the desert, especially in a wash like this. You have all these rock specimens on the ground here. And obviously, a lava is underneath all of this. Here's some that's exposed through a million of years of erosion. No telling how many feet thick this lava is below the ground here. Today was such a beautiful day. That those beautiful clouds and the blue sky, nice cool temperatures, perfect conditions for a short little hike off North Shore Road. Here we're coming up on that yellowish tan silty material, a different depositional environment, and it's again, it was part of it's been exposed through erosion because of water flowing through here for a long, long period of time. But you can see coming up on the right, it's interesting how this yellowish tan sedimentary material is on top of the lava flow this time. This basaltic flow is on underneath this yellowish tan material. I don't know. It just seems like this lava is different. It does. It's like water didn't hit it. It has the appearance of just ordinary lava. So it's this is another flow that occurred in a time when there wasn't a lot of moisture, and then the environment changed, and maybe a lake or something. The water came back and deposited all this yellowish brown material over a million years or whatever. But see that lava just doesn't look like the pepperite material. I could be wrong, but something's different here than the previous one that was the red sandstone. Again, I plan on coming out again and taking more pictures and studying this further. It's just too fascinating to do it in one trip. Well, anyway, coming up now, uh, parts of this looks like a volcanic tuff, but then other parts, especially the top part that's grayer looking, it's something different about it. It's in one area, it's real light. It's almost like it's a pumice. Yes, this material here is, it shows this unusual characteristic. The top layer, it's like it's something different. It's almost like a rhyolite type lava, maybe, or something. But the bottom is tough, and then you get this other material at the top here that, yeah, there's a piece of it. I'll have to come back and study that a little more. I don't know if some of it's like a pumice-like material, or it's just a rhyolitic type lava, maybe. Or it could just all be a volcanic tuff from different eruption periods with different chemical compositions and depositional environment when it fell to the ground. Upcoming here is just a real tall, like 20-foot thick section of a lava flow, basaltic lava flow. No telling how many feet underneath the ground here it extends down to. And some more pictures. And coming up is another example of lava hitting this red sandstone unit again, and its interaction. This is one of the more spectacular ones of this video right here. And these are a bunch of pictures of this particular location. In these slides, you'll notice the green mineral deposits. I'm thinking that might be olivine, but on my next trip out here, I want to take a piece of that and bring it home and take some close up pictures. But that greenish hue is out here throughout this hike. I'm thinking it's olivine. There's a picture of it right there in the center. But the composition of that lava, where it's reacted with the soils, broken up into pieces. And again, as usual, that contact point between the lava and the red sandstone, it's kind of like a metamorphic contact, and how the heat reacts with the sandstone and other sediments is a topic all to itself. But anyway, folks, I hope you enjoyed my video here. And again, I do plan on coming out here again several more times to do a more in-depth investigation of these various formations.